Hello, everyone. In this video, I will be going over how to run the actor-partner interdependence mediational model using Lavaan. So in this video, we will first start by setting our working directory as we would in any R session. And so I'm on a Mac, so I will go up to Session, Set Working Directory, and then choose directory, and then find the folder in which my data are embedded. And there's my SPSS file that I will be using. And so I will just hit open. And as you can see, our /Lavaan is confirming that we have set the working directory. We will be using a couple of packages, specifically Haven to bring in the SPSS data. We'll be using Lavaan to estimate the actor-partner interdependence mediational model. And then we'll also use lavaanPlot to create kind of a rudimentary visual representation of our findings. So the first thing we'll do is we'll create our data object using the read_sav command that tells Haven to read in a .sav file or an SPSS file. You can also do a .dta in Stata, or you can do .dat in other formats that SAS can use. And so we will first run those to create, to load those the programs as well as the data object. And then we will move down to the APIM mediation model, which is right here. And so we are first going to specify our mediator being predicted by both the independent variable for both partners. So remember, in the actor-partner interdependence model, we have dyads. It can be heterosexual couples, gay couples, parent-child. It could be boss and employee. It could be any number of different things, but we have dyads. So we have nested data, and we want to understand to what extent they influence each other and their own outcomes. So here we are going to have relationship mindfulness serve as our dependent variable, and we want that to be predicted by each partner's depression. So we have relationship mindfulness underscore comp tells me that it's a sum score or an average or a mean score. And then we have underscore M to indicate the male partner. In this data set, we are using heterosexual couples. And so we have depression here, the CESD underscore M to indicate male depression. And then we also have CESD without a label, without that underscore M to indicate female depression. And so what you'll notice here is that I have, the regression indicator, the tilde in Lavaan. So this relationship mindfulness is being, for males, is being predicted by both partners' depression. And I've also attached labels to them. And I chose A1 for actor, it's the first actor effect in our model. And I chose P1 for our first partner effect in the model. All right, and that will come in later when we are calculating our indirect effects. And so we do the exact same thing for the female partner. We are having the female's partner level, self-report level relationship mindfulness being predicted by their own and their partner's reports of depression. All right, so next, before moving on, this is the standard actor-partner interdependence model, that baseline model where you have one variable, one independent variable for each dyad member and a one dependent variable for each dyad member. And then we're going to build on that right here by adding in a third variable, which will be relationship quality. All right. And so relationship qualities, we're using the couple satisfaction index and then underscore comp to indicate, again, a mean or a sum score, then underscore M to indicate male. And then this is actually going to be our dependent variable. And so relationship mindfulness will actually be our mediator, and depression will be our independent variable. And so we have male partners' levels of relationship quality being predicted by male and female reports of depression. So this is our C prime path. Right? So this is going to be a direct effect between our IV and our DV. And then we're also going to have our two mediating variables for both partners, which will be relationship mindfulness. All right. And as you can see, I've thrown additional labels on there to indicate actor effects, So if it's male to male, then it's an actor effect. And then if it's female to male, then it's a partner effect. And I've specified that for each dyad member. All right. And then we also have the covariances between each set of variables across partners. And so remember, the way we account for the nesting within the actor-partner interdependence model is through our partner effects, but also through our residual covariances, because the extent to which I am relationally mindful and when I communicate with my partner is probably going to be correlated in some way with how mindful my partner is. Likewise, my symptoms of depression are probably going to be correlated with their symptoms of depression. How happy I am in my relationship is probably going to be correlated with how happy my partner is in the relationship, right? And so here's again, a complex code. And so I've created this very brief kind of PowerPoint to indicate the model that we will be running along with each one of the model constraints, all right? And so this is, again, a visual representation of the APIM mediational model. So what we will see is that there are actually going to be 8 indirect effects that we can estimate, but we are only going to be going through just a couple of them because the syntax can be a bit wieldy, and once you get the basic idea of how to calculate the syntax, it'll be easy to estimate those other parameters, those other indirect effects. So shifting back over, we have our indirect effects here. And so again, I'm calculating only the actor indirect effects. So I'm calculating this one from male depression to male relationship mindfulness to relationship quality for the males. And I'm calculating female depression to female relationship mindfulness to female relationship quality. So these are 2 of the 8. So we could also calculate the extent to which female depression affects female relationship mindfulness, which then affects male relationship quality, or we could go female depression affecting male relationship mindfulness to male relationship quality through P2 and A5, or we could do a partner-partner indirect effect, female depression, male relationship mindfulness, female relationship quality. All right. And so we are just going to be estimating these actor effects. All right. So we are estimating, again, A1 times A5 to specify that indirect effect. So that's this parameter here. So this is CSI for males being predicted by relationship mindfulness for males. And then we have A1 here. And so this is relationship mindfulness being predicted by male depression. Right. And so we've also done that for females. And so in our first model, I'm introducing kind of some additional, more advanced aspects of Lavaan. And so first we have our fit object to indicate our model and our data set. Mean structure by default, I just always include that. For estimator, we have maximum likelihood. I typically use robust maximum likelihood, but for this demonstration, I'm just going to use traditional maximum likelihood because we will be doing some LRT tests. And when you have robust maximum likelihood, you cannot trust just the chi-square difference test as you would in a normal SEM because we have that scaling correction factor to account for. And so we would need to do some extra tests. And so for simplicity, I am just going to be using maximum likelihood. And then we have our summary where we are going to request standardized output as well as our R-squared because we want to know how much variance is being accounted for by our model. And we want our estimates unstandardized, but also in standard deviation units because that is a more meaningful metric. A lot of the times our scales, especially in the social sciences, they don't hold a whole lot of intrinsic value. So we want those standardized estimates. In this model, it won't be all that important, but We have mod indices. So when you have any number of degrees of freedom, anything greater than 1, you can request mod indices to see if there's any aspects of kind of local misspecification. If having those degrees of freedom, having those those parameters not estimated and having those restrictions in your model, if it significantly harms that model. So we will request them, but we will not get any output because our model is saturated. There are a total of 27 parameters in this model, which include means, variances, and covariances / regression coefficients. And we're going to be estimating 27 different things, which means we have 0 degrees of freedom. We're also, again, this will not apply here. We're also going to request residual output to identify local misspecification due to potential problems with just using global indices of fit, such as the CFI and the RMSEA. And then we will also create a rudimentary plot for our figure. All right, so we can kind of look at and see what we are estimating and what our results are, because it's easier to understand the findings and the applications through figures rather than just a table where it's, again, harder to connect. And so what we will do here is we will first, we'll go ahead and give this a run, and then we'll walk through the output. And so we have 27 parameters, and then we have 0 degrees of freedom. So I always, despite the model fit being perfect, despite having no degrees of freedom, I always check the fit statistics just to ensure I don't have a syntax error. Because if you get anything other than 0 here, then you have a syntax problem, because we are estimating, or should be estimating, every parameter that is possible. All right, so we'll scroll down, and we will now look at our regressions, and you'll see our labels have showed up here, the labels that we specified up here, also in the output. And so here is our unstandardized estimates in this first column, our standard errors, our z-value, and then our test statistic. And then we have our standardized all, which is our standardized or standard deviation unit metric for our regression coefficients. So as we can see, depression predicts male relationship mindfulness. That's this path right here. But the female, so that's an actor effect, and then this, the female partner's depression does not impact the male relationship mindfulness. So there is a non-significant partner effect. Likewise here, we have a significant partner effect, where the higher that men are in depression, the lower or the less frequently women are communicating mindfully with their depressed partner. Then we also have our dependent variable here, relationship quality for males. And as we can see, it is being significantly predicted by male depression, as well as female depression. So female depression is having a significant effect on male relationship quality above and beyond male depression, as well as male and female mindfulness, right? So this would be, again, another partner effect. And then this first one that I talked about is an actor effect. Looking at relationship quality a little bit further, we see no partner effect for females' relationship mindfulness. So the higher women are on relationship mindfulness, does not appear to influence male relationship quality above and beyond depression for both partners and male relationship mindfulness. Right, so you see that here, that we do have a significant actor effect. And then lastly, we'll take a look at female relationship quality. And we can see that depression for both partners is a significant predictor of how happy women are in their relationship. And then we also have male relationship mindfulness serving as a partner effect or an actor effect. Excuse me. This is an actor effect from women's reports of relationship mindfulness, and then this is the partner effect that is non-significant. So male relationship mindfulness does not predict female relationship quality above and beyond depression and female relationship mindfulness. Here are covariances among our variables. This is the covariance between relationship mindfulness between partners, and here's depression between partners, and here is relationship quality between partners. So since we are focusing almost exclusively on covariances in this analysis, intercepts isn't all that important. And we might just take a peek at the variances to see if there is variation, but everything is highly significant. So that's not all that important here. And then here is our R squared. So how much variance is our model accounting for in our mediator and our dependent variable? And as we can see, relationship mindfulness is being predicted significantly by depression. So there's 18.4% of male relationship mindfulness is explained by male and female depression. And then we also have female relationship mindfulness, just under 11% of that variation among the women in our study. That 11% of that variation is accounted for by male and female depression. And then our model does, I'd say, a fairly decent job at accounting for relationship quality. So it's at 26.9% and 27.3% respectively, accounted for in male and female. So here is our defined parameter section. So these are the indirect effects. So this is this section right here. And so what we have is our unstandardized effect, our standard error, our p-value, and then here is our standardized effect. And so we can see that the standardized indirect effect from male depression to male relationship quality through male relationship mindfulness is the standardized effect is negative 0.06 if you're rounding up, and the p-value is significant. So we do have a significant indirect effect here. And as we would likely expect, because remember that female depression was not a predictor of female relationship mindfulness, kind of breaking that mediational chain, we do not have a significant indirect effect here. It's a very, very small indirect effect, very close to zero. And as you can see, the p-value is not even close. Okay. So here's where our mod indices would be. Here's where our residual variances and covariances and correlations would be. And then we can see over here that we have, using the lavaanPlot package, a visual representation of our data. And so again, this will provide, the parameter estimates are kind of redundant from what is over here, but I included them so you can begin to connect the findings that we see in this table to the visual diagram that Lavaan has created. And so now what we are going to do is we're going to constrain some pathways, and just to see kind of what happens with our model. And so we'll actually conduct some likelihood ratio tests. And so what I'm going to do is I'm going to modify the model. I copied and pasted it. And so here's our first model up here. And then I just copied it down here. And so this will be APIM Med 2. All right. And so I'm first going to just fix all of the fit stuff, creating the new data objects and things of that nature. So we don't make any errors when we're comparing our different models, because that is where major sources of frustration can be. Or if you leave this as fit 3, it's going to plot your previous model. It's not going to plot your new model, which can be confusing, because we'll get different estimates in our output than we see in our model, and that can create a lot of confusion. So The first thing I like to do is to change all of these first. All right, so what we're going to do now is, now that we've changed everything to fit for in APIM Med 2, I believe I got all of them. We're going to compare, enter in our syntax to compare. So we'll have fit.3, which is our first model. And then we'll have fit.4, which is going to be this new model where we're going to impose some restrictions. So the first restriction that we're going to impose is, you probably saw in the first model that I had this commented out. We're actually going to compare the size of the indirect effects for male and females to see if they're significantly different, to see if implementing that restriction results in a significant chi-square difference test in our model. And so the indirect effects will still be freely estimated, but it's going to constrict them to be equal. So we'll have the same effect size for male and female partners in this model. So we can go ahead and save it, and then we can run our model, and we'll scroll all the way up. And so here is our output. So we have 1 degree of freedom because, again, that restriction that we are placing on the indirect effects results in this 1 degree of freedom. If we were to constrain the indirect effects for both to be 0, then we would have 2 degrees of freedom because that would be 2 restrictions. But here we only have 1. And so as we can see, our chi-square test is not significant. So even though our male effects was negative 0.06 and the female effects was around negative 0.01, those were not significantly different from one another. And so the chi-square reveals that it's not significantly different. Our CFI is still good. Our TLI is still good. Our RMSEA, I generally don't even bother with the RMSEA in these types of models because the RMSEA is pretty biased when there are a few degrees of freedom. And since we only have 1 degree of freedom, the RMSEA tends to either be 0 or it tends to be 0.06, 0.07, 0.08, 0.09, 0.10. So and that's work by Dave Kenny and colleagues in 2015 that has demonstrated that. So I don't pay any attention to the RMSEA in these smaller degree of freedom models. And so everything else here will be largely the same. We can kind of see our graphical output, and we can scroll down to look at our defined parameters. And we can see that this is our indirect effect for male and female, and that now it's negative 0.022, and it is not significant. All right, so our model is indicating that constraining these two to be equal doesn't harm the model, and that when we constrain them to be equal, the indirect effects are actually not significant. So this would be, I think, a fairly important finding, and this is something that you would report in your write-up, that you constrain the indirect effects to be equal, and it did not significantly hurt the model, and the indirect effects were actually non-significant. So one of the potential problems here is that we might not have statistical power to detect that small of a difference between the indirect effects. Even though we have a sample of 305 dyads, so 610 people, we might not have sufficient statistical power in order to detect that difference in those indirect effects. So if we were to subtract them off, the indirect effect would be the difference would be 0.05, and we might not have the statistical power. So that's something that we would also need to consider when interpreting these effects. And so that is going to be our this first model that we are going to run and use as a comparison. So now what we're going to do is we are going to run another model. And so again, the first thing I'm going to do is just change our model. And so we are ensuring that we are comparing the right models to one another. And so here, I'll be changing only fit 5. I still want my baseline model to be the source of model comparison. So what I could do is I could just impose an additional restriction on this model now and compare 3 to 4 to 5, but I'm actually going to change the restriction that we are imposing. Right, so I'm going to remove this restriction that we had just tested. We have our indirect effects, and so now we can go in and we're actually going to constrain the actor and partner effects to be equal across the entire model, so we can really look at the implications of model constraints. We can conduct the likelihood ratio test, we can look at local misfit, and we can see how constraining all of the pathways in our model, what it will do to our substantive findings. And so what I'm going to do is all of the actor paths, I'm now going to constrain them to be equal. And so we just changed the value labels here. So actor 1 for depression impacting male male relationship mindfulness is now congruent or constrained to be equal to the actor effect from female depression to female relationship mindfulness. And then we're also going to do the same thing for the partner effects. We're going to constrain those to be equal. All right, so the partner effects from depression to relationship quality are now constrained to be equal between the IV and the mediator. And so we can also do that same thing down here. And so we'll constrain the actor effects to be equal here. And we can constrain the partner effects to also be equal. So here. So this is female depression, male relationship quality, male depression, female relationship quality. Those are now the same. And so we can now move the partner effects to 5. So this is now constrained to be equal to this. And then we can do the actor effects as well, just by changing the value labels. All right. And so hopefully that is done correctly. And hopefully we don't run into any errors. And we will get numerous degrees of freedom. If my calculations are correct, it'll be about 6 degrees of freedom that we are going to be getting back. All right, so we can go ahead and we can run this model. Oh, so it looks like we ran into a syntax error, and so we need to take a look at that. It's going to be in our indirect effects, because now we have changed those. So actually, let's just get rid of those for now, because we are actually far more interested in what the model is going to be like. Just looking at the direct effects and constraining the paths to see how our model changes by making everything equal across male and female. So we can go ahead and we can run that to see if that does everything. So that was indeed the problem. And so we can take a look at our model fit. So recall that our baseline model had 0 degrees of freedom. All 27 parameters that were estimated, or that we could estimate, were estimated. And so now we are only estimating 21 of those parameters. And we have imposed 6 inequality constraints. So 27 minus 6 equals 21. So that's how many parameters we're estimating, and that's where our 6 degrees of freedom are coming from. So CFI is still looking good. TLI is still looking good. But it also appears that despite those fit statistics, not indicating a whole lot of model data problems in terms of misfit, our significant chi-square test is saying that there's actually pretty significant harm done by our model. All right. So we will go ahead and take a scroll down, and you will notice that the partner effects are the same. So our unstandardized effects are going to be identical. You will notice small differences in the standardized effects. And so here's our actor effects. They're constrained to be equal, and we have our partner effects constrained to be equal as well. And so we'll take a look down here just to be sure we're coding everything correctly. It looks like we have coded everything correctly. So we are in good shape. So here's our actor effect, and here's our actor effect. They're not necessarily in the same order. You can change that up just by the order in which you place them into Lavaan. But the way I have coded it, it does not create, this parameter one is not necessarily the same as parameter one over here. They're actually flip-flop for relationship mindfulness. So, but you can change that by just simply switching up the order in which you enter them into Lavaan up here. So we'll scroll down, and one of the things I immediately notice is that the R squared for men went down by about 6%. So before we were at 18.4%, I believe. Now we are down to 12%. And so what happened is that a lot of the effects, the regression coefficients, the regression parameters were larger for men than for women. And so by constraining them to be equal, those regression coefficients for males are actually got smaller and smaller and smaller and smaller. So moving over to the diagram, the effect of CESD for men on male relationship mindfulness. Before, this was 0.40, and now it is 0.24. And so our regression coefficient went down by about 40%. And so that's what you're seeing in the misfit in the model. That's where our chi-square is significant. And that is why our explained variance is also smaller. Is because before we allowed that parameter to have its own identity, and it was free to be you and me. But now that we're telling it you have to be this way, you have to take on a value of negative 0.24. And so the result is that the variance actually goes down in our dependent variable. And we see that now, all things being equal in our model, the model actually does a better job at predicting variation in women's, because again, if we think about that, men's effects were being underestimated, which now means women's effects are being overestimated. So those regression coefficients that were, negative 0.05 before, from female depression to female relationship mindfulness, it has now gotten about 4 to 5 times larger. So now it's accounting for more variation in our model. And so that's why you're seeing shifts in these R squared statistics. So here are mod indices. And so here is where we are, here's where the model is telling us that if we include these two parameters, then our chi-square is going to go down by about 12.38 for this one and 11.56 for this one. Modification indices can be really helpful if they are used thoughtfully and intentionally, but they can also be extremely dangerous because I believe it's work by Bud McCallum has done simulation research where if you just follow modification indices, you never get back to the population model, the correct model, the model with no misspecifications, because you're kind of just following what the data are telling you, and that's not always the best way to go, because sometimes we'll actually have a modification indice that pops up that doesn't actually make any sense. For example, like a time 2 variable being predicting a time 1 variable. Doesn't make sense. So if you just follow those mods, you're never actually going to get back to your correct model. So just be exceptionally careful with your mod indices, and be sure to have a theoretical justification for any modifications that you do have. And so we also have the residual matrix, and this is going to be an indicator of whether or not our parameters are over or underestimated based on what the model expects. And we see here relationship mindfulness and CESD for men. Again, this was that parameter over here, CESD to relationship mindfulness, that was 0.40 or negative 0.40 in the first model, but now is negative 0.24. And we are getting a negative value here, and this is a z-score. So that means that this parameter is being underestimated, all right? And so we also have here another z-score that is significant, and this is the opposite. This is for female depression to female relationship mindfulness, and this is a positive value. So that means this is getting overestimated, and that's happening because we have constrained those effects to be zero. That's where we are telling them you have to be equal to one another when they don't really want to be equal to one another. And those problems are showing up in these local fit statistics. And again, that is really what's contributing to our model data misspecification evidenced by our chi-square. And so just kind of scrolling up a little bit, you can see in our mod indices that the parameters that are really causing a lot of problems are the ones we've been talking about throughout this entire third model. It's the depression relationship quality variable across gender being constrained to be equal. Our model is still yelling at us. So we are seeing a lot of consistency in where the problems are. So that tells us we need to release those constraints. And so down here, we get redundant information as above, actually, because when you have a saturated model and you do a chi-square difference test, it is just going to be your chi-square test right here. But if we were to have a model where we had existing degrees of freedom, we had placed restrictions on a model, we would need to do this to determine whether or not the significance difference, the difference between the two models was significant. You could also do it by hand and do it the old-fashioned way by establishing your degrees of freedom difference, your chi-square difference, and then looking that up in a table. But again, modern technologies allowed us to actually conduct the chi-square difference test. So this is a basic introduction to the actor-partner interdependence mediational model. We've talked a little bit about basic estimation. We've talked a little bit about parameter constraints around constraining, specifically the direct and the indirect effects to equality. And we can see kind of what are some of the implications of constraining these effects to be equal. So hopefully this video was helpful in allowing you to not only understand kind of the basic estimation of the actor-partner interdependence mediational model, but also take you a little bit deeper into some more advanced topics. And you can see some of the problems that can arise in our structural equation models when we have a misspecified model. So thanks very much for watching.